Hello, friends, and welcome back to the Heavy Machinery channel, your ultimate destination for jaw-dropping machinery and heavy-duty equipment that's built to impress. Today, we're giving you an exclusive insider's look at the most powerful machines on the planet. Get ready for some serious industrial action. Ultra-large gear milling technology is critical for producing high-precision gears used in heavy industrial machinery, such as cement grinders, thermal power stations, and ball mills. These gears need to withstand enormous stress and operate smoothly under extreme conditions. The manufacturing process involves several steps to ensure high durability, accuracy, and efficiency. The milling of ultra-large gears begins with selecting high-quality raw materials, often alloy steel, known for its strength and ability to resist wear and tear. The gear blanks, which can weigh several tons, are first forged or cast and then heat-treated to achieve the desired hardness. Next comes the machining phase, where milling and turning are performed. Ultra-large gear milling utilizes specialized CNC, computer numerical control, milling machines, equipped with large worktables and robust spindles. These machines are capable of handling the immense size and weight of the gear blanks while maintaining precision. The gears are cut with extreme accuracy using a combination of roughing and finishing passes. The roughing phase removes the bulk of the material, while the finishing pass ensures that the teeth profiles are precisely cut according to specifications. Turning, on the other hand, is used to machine the gear's outer diameters and faces, ensuring a balanced and symmetrical design. For ultra-large gears, turning requires equally large and powerful lathes, often capable of rotating gears several meters in diameter. One of the critical challenges in this process is managing thermal expansion due to the heat generated during machining. High-precision temperature control is necessary to maintain tight tolerances, preventing deformation of the gear. Additionally, advanced inspection systems, such as coordinate measuring machines, CMMs, are employed to ensure the gears meet exacting standards for size, shape, and tooth profile. The final gears are often used in high-demand industries like cement manufacturing, where they play a crucial role in driving massive grinders, or in thermal power plants, where they support critical rotating equipment, ensuring smooth and efficient operations. The manufacturing process of large kiln tires by Areta is an impressive display of industrial expertise and precision engineering. Kiln tires are crucial components in rotary kilns used in various heavy industries, including cement production, metallurgy, and mining. At Areta, the production begins with selecting high-quality raw materials, usually steel alloys, to ensure durability and resistance to extreme temperatures and pressures. The steel is heated in a forge to high temperatures, allowing it to be shaped under extreme conditions. This forging process involves hammering, pressing, or rolling the steel into the desired cylindrical shape. The forging method ensures the material's mechanical strength and homogeneity, critical for a kiln tire's functionality. Once the forging is complete, the large cylindrical tire undergoes precision machining to achieve the exact dimensional requirements. Areta employs advanced CNC, computer numerical control machinery, to ensure the tire's inner and outer diameters, as well as its thickness, meet stringent tolerance standards. This guarantees that the tire will fit perfectly around the rotary kiln without causing uneven wear. Following machining, the tire undergoes heat treatment, which enhances its toughness and wear resistance. This step is essential for extending the tire's service life, as it will be subjected to constant mechanical stresses and high temperatures in operation. The finished kiln tire is then meticulously inspected for defects, ensuring it meets all quality standards before being delivered to customers. Verada's expertise in forging large kiln tires ensures that their products are reliable and long-lasting, capable of withstanding the harsh operating environments of rotary kilns, through decades of innovation and strict adherence to industry standards. The Jongyuntech ZC600H is a state-of-the-art corrugated pipe production machine designed for maximum efficiency and output, capable of reaching an impressive speed of 4 meters per minute. This machine excels in the production of high-quality ID 200 mm corrugated pipes, making it ideal for industries requiring robust and durable piping solutions. One of the key features of the ZC600H is its focus on precision and quality, ensuring each pipe meets stringent industry standards. It utilizes advanced technology to maintain consistent pipe dimensions and durability, while its high-speed capability significantly enhances production efficiency. This level of performance not only reduces the ZC600H is also noted for its energy efficiency, lowering operational expenses while maintaining top-tier output. Its robust design ensures longevity and durability, making it a reliable choice for manufacturers seeking to boost productivity without compromising quality. Overall, the ZC600H stands as a powerful and efficient solution for corrugated pipe production. Heavy machining involves precision work on large-scale components like rotor shafts, castings, and forgings, often in materials like superalloys. A prime example is the machining of a 25 metric ton rotor shaft, a process that demands specialized tools and techniques. One such tool is the SCMT-38, a screw-clamped positive insert designed for cost-effective and secure machining. A key element in heavy machining is the material removal rate, MRR, which refers to the amount of material efficiently cut away from the workpiece. This process requires long periods of continuous cutting, during which significant heat is generated. To manage this, the insert used is coated with Duratomic TP0500, a highly wear-resistant material that withstands the heat and extends the tool's life. This process highlights the complexity of metal cutting, where manufacturers face challenges like heat generation, wear, and precision. Seiko Tools provides turning and profiling solutions to meet these challenges, offering secure and productive options for machining large castings and forgings. Their focus on materials such as superalloys ensures durability and performance. The manufacturing process begins with steel billets, which serve as the raw material. These billets are first placed in a reheating furnace where they are heated to the recrystallization temperature. At around 1,200 degrees Celsius, the steel's internal crystalline structure is reformed, becoming more ductile and ready for rolling. Once heated, the billets are passed through roughing mills, which applies significant pressure to reduce the billet's dimensions and begin shaping the steel. This initial rolling stage prepares the material for the more detailed finishing stages by creating a uniform cross-section and eliminating any surface defects. After the rolling process, the steel products undergo controlled cooling in a cooling bed. The rate at which the steel cools is carefully monitored to ensure that the mechanical properties such as strength, hardness, and ductility are retained. This cooling process also prevents internal stresses and warping, ensuring that the rebar and wire rods are structurally sound. After rough rolling, the steel enters the finishing mills, where the rolling process becomes more precise. For rebar, the steel is rolled into long bars, with a critical step in this stage being the formation of ridges or deformations along the bar's length. These ridges are essential for ensuring a strong bond with concrete in construction applications. For wire rods, once the products have cooled, they are sent for final inspection, cut to the required lengths, and bundled for shipping. Rebar is typically cut into uniform lengths and bundled for easy transport, while wire rods are coiled into large spools.